In this video, we are going to look at Unit 8, Lesson 6, which is about the addition rule. By the end of this lesson, you're going to be able to use the addition rule to determine the probability of event A and B happening, and also the probability of event A or B happening. So on page 304, we see this table, and it is the results of a survey at a neighborhood park of people who are wearing a hat or wearing sneakers. So go ahead and use this table to answer the questions on page 304 and then come back to the video. All right, so number 1 says that Andre says that the number of people wearing sneakers or wearing a hat is 21 because there are 10 total people wearing a hat and there are 11 total people wearing sneakers. So is he correct or is he not correct? And he's incorrect because when he just totals these two numbers up, he actually counts these people twice. So he ended up saying, all right, there's 8 plus 3 people wearing sneakers, and then there's 8 plus 2 people wearing hats. And so the people that were wearing both a hat and sneakers ended up getting counted twice. So the actual number of people wearing sneakers or a hat, we have 3 and 8 is 11 and 2 is 13. So the probability that somebody is wearing sneakers or a hat is 13 out of the 25 total people in this survey. So then on page 305, we've got Jada saying that she has a way to find the probability of a random outcome being an event A or B. She says we use the probability of the outcome being an event A, then add the probability of the outcome being in category B. Now, some outcomes have been counted twice, so we have to subtract the probability of the outcome being in both events so that those outcomes are only counted once. So here's her method. If we're looking for A or B, so in this case, we had sneakers or hats, you could look at the probability that they're wearing sneakers plus the probability that they're wearing hats, and then subtract off the probability that they're wearing both sneakers and hats. So this would have helped us in the first example because we had 10 out of 25. We had 11 out of 25, and then we had 8 people being counted twice. So this would have given us that 21 minus 8, which would give us the 13 that we counted in the table. So let's take a look at this table then on page 305. So this is information about the 50 states in the United States and their population. So event A is that the state name starts with the letters A through M. And so, that's the number of states that start A through M. The other option would be that they don't. So they start N through Z. Event B would be that the population is less than 4 million. So these are the states with less than 4 million population. And these are the states with at least 4 million, so 4 million or more. So use this table to answer the questions on page 305 and then come back to the video. All right, so taking a look here in the paragraph, it had us label some different things. So it said Alaska is one of the 12 states in the top, and it should be 11 states, is one of the 11 states in the top left cell of the table. California is one of the 15 in the top right. Nebraska is one of the 13 in the bottom left. And then New York is one of the 11 in the bottom right. And so now it wants you to go ahead and name which of the states are in each outcome. So which states are in event A, which I've highlighted in green. So remember, A was that their names started with A through M. And then B was that their population was less than 4 million. So which ones are either starting with A through M or they're less than 4 million? So we've got Alaska and California from event A, or Alaska and Nebraska for event B. So Alaska, California, and Nebraska fit in A or B. How about just A? So which states are in event A? And that's going to be Alaska and California that start with A through M. Which ones are in event B where their population is less than 4 million? So less than 4 million is here. So that's going to be Alaska and Nebraska. And then which ones are in both event A and B where their name is A through M and they're less than 4 million? And that's just going to be Alaska in this case. So then let's go ahead and find the actual probability of each event. So now this is utilizing the numbers in the table. So find the probability that just one of the random 50 states, okay, one of the states is in event A or B. Okay, so if it's in event A, we'd have 11 or 15 to choose from. And then adding in also that it could be in event B would be this 13. So we have all of these. So if we add this together, 13 plus 11 is 24, plus 15 is 39 out of the 50 total states. What's the probability that it's in event A, that it's a state that starts with A through M? So that's just going to be in this top row. So 11 plus 15 is 26 states out of 50. What's the probability that it's in event B? That it's less than 4 million. So how many states are less than 4 million? And that's 11 plus 13, which is 24 states that are less. And then how many are in events A and B? So they start with A through M and they're less than 4 million. So they have to be in both. So that's these 11 states out of 50. And then does Jada's formula work for these events? So remember that her formula was that if we're looking at the probability of A or B happening, that's going to equal the probability of A plus the probability of B minus the probability of A and B. So we know A or B is 39 out of 50 in this case. The probability of A was 26 out of 50, that it starts with A through M. The probability, out of 50, not 25. The probability that it had a population less than 4 million is 24 out of 50. And the probability that it was in both of those was 11 out of 50. So 26 plus 24 is 50 minus 11 is in fact 39. So this does work. So yes, her formula did work there. All right, then number 4 has a lot of words in it. So make sure that you read through it once to figure out the just kind of context of the problem. And then I like to start highlighting different things that are happening and trying to highlight the different events. So we see in here that it's talking about seniors at a high school are allowed to go off campus if they have a grade of all A's in their class or perfect attendance. So we know we're looking at an or probability here. And then we've got the 2 events. Okay, so we've got this event A is all their classes have A's. So A's in all classes. And then the other event is perfect attendance. So B, we could say, is perfect attendance. So I wrote out Jada's formula here. Okay, A or B happening equals the probability of A plus the probability of B minus the probability of A and B. And I'm going to start filling this in now as I'm reading. So, and An assistant principal in charge of academics knows that the probability of a randomly selected senior having all A's. So here's your event A probability. So this is the probability of event A happening is 0.1. An assistant principal in charge of attendance knows that the probability of a randomly selected senior having perfect attendance is 0.16. So here's your probability of the event B happening. And the cafeteria staff knows that the probability of a randomly selected senior being allowed to go off campus, which means that they either have all A's or perfect attendance, is 0.18. So the probability that A or B happens is 0.18. What is the probability that a randomly selected senior has both perfect attendance and all A's? So if we plug into this equation, we can just look to solve for this probability. We'll balance out both sides. So we have 0.18 equals, and we'd have 0.1 plus 0.16 is 0.26 minus the probability of event A and B. So what would we need to subtract from 0.26 to get to 0.18? So you could do 0.26 minus 0.18 and find out that that's 0.08. So this probability right here of A and B would have to be 0.08. That's the number of people that end up being counted twice that have both perfect attendance and all A's. So the probability of A and B equals 0.08. All right, so that is the addition rule. So make sure that you have that written down somewhere in your book. You could put it in your summary at the bottom of the page there. It's actually at the top of your summary also, but I would just make sure that you have that handy. So in the addition rule, can we apply that to the people in the park, which we talked about earlier? But event A was wearing sneakers or a hat. So event A was wearing sneakers. Event B was wearing a hat. So your addition rule, okay, like we talked about, we already know if they're wearing either or is these 13 people. And then the probability that they're wearing sneakers is 11 out of 25. That they are wearing a hat is 10 out of 25. And that they're both is that 8 out of 25. So 11 out of 25 plus 10 out of 25 minus both gave us that 13 out of 25. All right, then in 6.3, we've got a couple word problems to break apart here. So I'll just break them apart with you. So let's read through the situation and then let's go in and start identifying what we need. So at a cafe, customers order at a coffee bar and then they either go to another table where the cream and sugar are kept or they find a seat. Based on observations, a worker estimates that 70% of customers go to the second table for cream or sugar. The worker also observes that about 60% of all customers use cream for their coffee and 50% of all customers use sugar. Use the worker's estimates to find the percentage of all customers who use both cream and sugar for their coffee. Explain your reasoning. So what I like to do is go in and see what it is I'm supposed to be doing. So at the end there, it said use the worker's estimates to find. So we're looking for the percentage of customers who use both cream and sugar. Then I like to go back and look at any other numbers that would help with that. So we go back in and it said, based on observations, a worker estimates that 70% of customers go to the table for cream or sugar. The worker also observes that 60% of customers use cream and that 50% of customers use sugar. So this is a probability of an or event, okay, because we have that they're using cream or sugar. So let's actually write out the addition rule for cream or sugar as our two events. So the probability of cream or sugar is going to be the probability that somebody uses cream plus the probability that somebody uses sugar minus the probability that they use both cream and sugar because we've counted them twice. So in the beginning here, they say that 70% of customers go for cream or sugar. So we know that the probability or the percent of people that go for cream or sugar is 70%. Then it says 60% of customers use cream. So the probability that somebody's using cream is 60%. Then it says that the probability that somebody is using sugar is 50%. And then we want to find the probability that they used both cream and sugar. So now we just need to balance out both sides of this equation. So now we have 70% equals 60 plus 50 is 110% minus the people who use both cream and sugar. Okay, so what percent do we have to subtract off of 100 to get to 70? So again, you can do 110 minus 70, and that tells you that you need to subtract off 40%. So the people that use both cream and sugar are 40%. So 40% of customers use both. All right, number 2, at a grocery store, 70% of the different types of juice come in a bottle holding at least 400 milliliters, and 40% of the different types of juice come in a low sugar version. Only 25% of the juice varieties are in bottles holding at least 400 milliliters and have low sugar version. What percent of the different types of juice come in a bottle holding 400 milliliters or are low sugar? So we see again that we've got this and idea. Okay, so they're doing and they're doing or. So let's write out our addition rule. So the probability, and this is talking about at least 400 milliliters or low sugar. So I'm going to write out probability of 400 or LS for low sugar. So that's going to be the probability that it's 400 milliliters plus the probability that it's low sugar minus the probability that it's both 400 milliliters and low sugar. So let's go in and start identifying where we see this happening. So 70% of the types of juice come in a bottle holding at least 400 milliliters. So this is the probability of 400 is 70%. Then we see that it says, and 40% of the different types of juice come in low sugar. So 40% are coming in low sugar option. Only 25% of the bottles, only 25% of the juice varieties are in bottles holding at least 400 and low sugar. So 25% are both of these. So what is the probability that it's 400 or low sugar? So now we can just simplify this side of the equation and it'll give us our probability that it is 400 or low sugar. So 70 plus 40 is 110% minus 25% gives us the probability that it's 400 or low sugar is in 85% of the bottles. All right, so let's use our data from the last activity to figure out some more probabilities here. So one thing that we know in this table before we get started is we see that the total less than 400 milliliters is 60 bottles, and at least 400 milliliters is 140 bottles. So this is telling us that we have 200 bottles total in this table. Then we also see that the total low sugar is 80. So the no low sugar available would be 200 minus 80 or 120. Now we need to figure out what goes into these other cells. So we know that if it's at least 400 milliliters and low sugar, so 400 milliliters and there's a low sugar option, that's 25% of the bottles. Okay, 25% of the total bottles. So let's do 25% of 200. And so you can do 20.25 times 200. You can think of 25% as 1/4. So 200 divided by 4. And we get 50 bottles in this category that are both low sugar available options and are at least 400 milliliters. This then allows us to fill in the rest of the table because we know the total low sugar options is 80. Well, if 50 of them are above 400 milliliters, then 30 of them are below. 80 minus 50. This also helps us here because we know that there's a total of 140 options at 400 milliliters. 50 of them are low sugar available. So 140 minus 50 means there are 90 options that have no low sugar availability. And then we see the total of less than 400 is 60. 30 of them are low sugar available. So 30 of them are no low sugar. And then you can check here that 30 plus 90 equals 120. So now we can go ahead and fill out some probabilities about the rest of these. So what's the probability that it's less than 400 milliliters? So less than 400 milliliters would be all of these. So less than 400 milliliters, there's 60 out of 200 bottles. And then you could certainly divide that to get the decimal, which is 0.3, or the percent is 30% of bottles. No low sugar available. So the no low sugar available is here. And so the total no low sugar options are 120 out of the 200. And 120 divided by 200 is a decimal of 0.6, which is 60% of the bottles have no low sugar option. So which ones are no low sugar available or less than 400 milliliters? So no low sugar available is here, or less than 400 milliliters. So also this one. So these are less than 400 and no low sugar. So we've got 60 plus 90 is 150 out of the 200. So 150 divided by 200 is 0.75, which is 75%. And then which ones are no low sugar and less than 400 milliliters? So which ones are in both of these? So less than 400 milliliters and no sugar is 30 out of the 200. And 30 divided by 200 is going to be 0.15, or 15% of the options. So how do you know, how did we know that we needed to do addition rule in this first question? And because we're seeing that people are using cream or sugar, so they could use either or they could use both. So some people put both cream and sugar in their coffee. Some put either or. And then how did we figure out the probability of no low sugar and less than 400 milliliters for question 3? So the and was where they overlapped. So we just looked in the table. By filling out this table, we could just isolate down to which ones were and. So or was in either of them, and was in both of them. And so if 100% of the class was wearing sneakers or jeans, 80% of the class is wearing sneakers, and 70% of the class is wearing jeans, what's the percent that's wearing sneakers or jeans? So remember, when we're doing sneakers or jeans, okay, that's the probability of sneakers plus the probability of jeans, and then minus the people who are wearing both so that we don't count them twice. So we've got 100% of the class is wearing sneakers or jeans, 80%. Oh, what is this? This should probably say and. So 100% of the class is wearing sneakers or jeans. The probability that's wearing sneakers is 80%. The probability that's wearing jeans is 70%. So how many are wearing both sneakers and jeans? And so we have this is 150% versus we know we need it to be 100%. So that means we counted 50% of the people twice. So 50% of the people are wearing sneakers and jeans. All right, so why is the addition rule useful? So it helps you to solve for different probabilities. So we, if we had probability of event A, probability of event B, you could know A or B. You could know A and B. So if you know any three of these, you can solve for the missing one. So if we knew the probability of A, we knew the probability of B, and we knew the and, you could solve for the or. Or if you knew A and you knew A or B and you knew A and B, you could solve for just B. So it allows you to figure out different situations there. And so describe a situation where you could apply the addition rule. So we could say, what if we know that the number of students, the probability of students who are in a club or play a sport is equal to 80%. And then we also know that 70% are in a club. So let's say the people that are in a club is 70% and the people that play a sport is 60%. So how many people are in both a club and a sport? So if we add club and sport together, we get 130%, and we know it needs to be 80%. So we can figure out how many people were counted twice by the difference of those 2%. So the people that play a club and a sport, okay, is 50% because 130 minus 50 gives you 80. So you have 70% of people are in a club, 60% are in a sport, 50% do both. And then how does a Venn diagram look for a situation like this? So if we had, here's our club, here's our sport. So you have 50% of people that are in both, and 70% are in the club. Well, 50 are in both, so that leaves 20% for just the club. Okay, or 50%. So here's the sport is 60%, so 10% are just in a sport, not a club. And then you know the total of that is 80%, so you know 20% aren't in either. All right, so hopefully after watching this lesson, you can use the addition rule to find probabilities. You can check your understanding with the lesson 6 practice problems. If you need more help with those, be sure you check out the video that I have going through each of the practice problems. And then you can also check your understanding with this cool down, and be sure to reach out to your teacher if you are struggling.